I want to thank SAMCEDA for giving us this honor, and I also want to thank the city of Redwood City for being our home base for the last 2 years. So we moved out here in 2000, I guess actually about 2013 from North Carolina, and it's been a fun ride since we've come. So a little bit about our company. We're a new state-of-the-art 3D printing technology. We have about 135 employees today. We've raised $141 million in venture capital from some of the best venture firms, including Sequoia, Silver Lake, Google, etc. And what we really invented was a new way to think about fabricating products. We kind of stick out like a sore thumb here in the Valley. There's a lot of people that do software, there's a lot of people that do hardware, and we kind of have material science also thrown in, which is exciting and allows us to get some of the best talent in the world. But to take you through a little bit about what we're working on, let me take a step back and tell you a little bit about the 3D printing market today. And there's been a lot of people that have hyped 3D printing for a long time. And if you look at it, it's been mostly in the prototyping market. So some of the top companies in the world, before they deliver the products that you know and love, they prototype it using additive technologies. And it's about a $4 billion market. It's growing 30% a year, so it's still fairly small. I always joke that scented candles is a $10 billion market. So to kind of give you an expertise, it's still a fairly small market. But it's highly fragmented. Across anyone that makes physical goods, you're essentially going to be prototyping them first. And so when you look at kind of why it's always stuck in the prototyping market, additive gives you a lot of things. One is complexity is free. You don't have the design rules that you would traditionally have with traditional manufacturing. You have zero lead time. I can design a part, send it to a printer, and have it out within a decent amount of time, 24 hours or less. And then there's essentially zero skilled labor involved in order to actually get these machines to run. It's not like somebody's programming a CNC machine or so on. However, it's had a lot of issues. One is speed has been a major problem. If you look at, I think Meg Whitman described watching a 3D printer was like watching ice melt. Essentially, you can put an object in, you come back, and maybe a couple hours later you'll see something, but really, really slow process. The other issue is material properties. So if you look at kind of polymer processes, that they're layer by layer production of a three-dimensional object. That's how these 3D printers work. You're essentially extruding a plastic on top of itself over and over and over again until you create your object. The issue is you have poor interfacial adhesion between those layers, and so you have poor mechanical properties. They don't behave like injection molded parts, which is a major issue, which is why people have traditionally stuck with the manufacturing processes that people have loved and that are tried and true. And that's the main reason why we think 3D printing is in the chasm. It's kind of failed to cross that in the manufacturing sense of the word. If you look at the process that we developed, we launched this on TED stage about actually a year ago. We developed this process that we call CLIP, which is continuous liquid interface production. And essentially, we developed a way to continuously print something. So instead of doing that layer by layer thing that you would see traditionally from a MakerBot or some of the other SLA processes, we grow our parts out of a pool of liquid. And this was something that was a major breakthrough when we first did it. I believe we had about 3 or 4 million TED views in a span of a week, which was pretty impressive. But this process allows us to bridge that speed gap that has held back 3D printers historically. The other thing that it does is our parts, they come out and they have no layers. They have smooth surfaces and they behave like injection molded parts. They have invariant mechanical properties. So we can actually print things that can go on a vehicle and no one can know the difference. So we've had a lot of success, particularly in those applications. This is the printer that we're actually bringing to market. No one really has seen this yet. So in next month, we will be launching this. There'll be a big piece in Bloomberg. And this printer is essentially a new way to view capital equipment. It's a connected device. They're streaming about 80 million data points a week. And it allows us to provide a great customer support and a closed loop feedback that is traditionally not seen in additive to date. And it allows us to go after a lot of great applications. And so here's a couple of them. The one on the left is actually an electrical connector. It's not a super exciting thing, but if you look at that market, it's a $37 billion market. And you look at the amount of effort that goes into manufacturing that piece, that little plastic piece that you see all over automobiles and aerospace and any sort of consumer products, it takes roughly around 6 months to make that injection mold. It costs about $500,000. And so typically you do not design your own electrical connectors. You use the ones that Ford and GM and Toyota have designed and built in masses. This part, we dropped off a machine at one of these electrical connector partners of ours. Within 2 hours, they were able to print this off and CT scan it. And not only did it have the dimensional accuracy needed to be production, but it also had the material properties that were identical to what you would see in a production application. And so you can actually now do low volume manufacturing. If you want, or like Tesla, and you make 50,000 automobiles, you don't need 1 million electrical connectors. And so now they can come and custom design their own electrical connectors and have them made. The object on the right is an elastomer puck. We have a big partnership with a large athletic footwear company that I'm not allowed to mention. But the whole goal there is to actually release a shoe that's custom designed to you. The whole concept of shoes being size 11, size 12 is baloney. It should be size Phil or size Alex. And they should be designed to your needs and designed to your foot structure. And so those are the types of things that we're working on. We have a wide range of materials that show a lot of opportunity across many applications. We have a rigid polyurethane. This would be similar to what you would see from nylon and ABS-like applications for automotive and interior and exterior automotive parts. We have about 600 cars driving around Munich, Germany with BMW right now with our parts on them, doing field testing that are ultimately resulting in us looking at 27 parts that we will go into production with them in 2017 and 2018. We have a semi-rigid polyurethane, which behaves just identically to injection molded polypropylene, which is the most injection molded material on Earth. And there's no way to 3D print polypropylene today, so that was a major breakthrough. We designed that with Ford as being a major issue. The elastomer I showed you, and as in the cyanate ester, which is essentially similar to what you would see from Ultem. Ultem is a material that you can use in under-the-hood applications like automobiles. So we do a lot of air intake valves, some stuff for F1 and NASCAR and so on. Ford developed this slide, which essentially is comparing our materials to the most injection molded materials they use. Again, one of the big breakthroughs here is that our materials behave like injection molded materials. This is something you do not see from additive today. And what this does is it helps educate their engineers that there's a new process that you can design for. If you look at it traditionally, the toolbox for manufacturing that you see that engineers have, 3D printing is not in that toolbox. And so we have to educate them to get it in there so that they have a new way, new approach to design. Huge into software, again. If you look at what we're doing, it really is at the intersection of hardware, software, and molecular science. We have one building, everyone works shoulder to shoulder, and that's important in order to make this work. And so when you look at it, we have auto support generation for the parts, as well as real-time data feedback and network effect improvements. Traditionally in additive, if you had a failure, you're kind of on your own as a user. You have to figure out and tweak it the way in order to get it to come out right. Our users, they hit the help me button, beams back the failed data, we beam down the appropriate way to print it, and our algorithms get better. Very the same way as Google had search early on when it was kind of okay, and it's traditionally gotten better and better and better with time. We have a very same focus here. And so what we bring with Clip is that we bring all of those advantages that additive have, but also with the advantages that you would see from traditional manufacturing. So we can do low to medium volume with the surface finish that you'd expect and the mechanical properties you expect from production parts. And so with that, we think that we will be able to bridge that gap between, there we go. bridge the gap and actually cross the chasm into manufacturing with something that additive hasn't really done yet today. Again, we have a large customer base. We're proud to have 23 customers in the field with our machines today. We were about to be doing another big launch of them, but we actually had 40% of them come back and order their second, third, and fourth machines. And this is a big statement for a startup like ours. For repeat customers to come and buy extra machines, additional capital equipment, shows that their investment in us, and we're doing some unbelievable things with them. Again, the whole concept is taking something that's been traditionally prototyping and building a factory of the future. And what this takes is a concept of, instead of sending all of our parts to China and have them manufactured and sent back here, you have the concept of decentralized manufacturing. You can manufacture anywhere. So the folks that we're working with, like our athletic footwear partner, Ford, BMW, the whole concept is building the parts where you need them. And so they will be opening up their factories for the first time here in the US, or the athletic footwear partner hasn't made anything here in the US since the 1980s. And this will be the first time that they're actually manufacturing things here in Portland and so on, so it's pretty cool. We also are doing a lot of work in life sciences, from things like biodegradable microneedles all the way to corrective orthodontics, and to surgical guides. We have a big partnership with J&J that was announced recently, where we're working on surgical guides and surgical implants 3D printed that are custom to you, right? What's great is a lot of these applications, they're better, you can offer better treatments if you make the products to the patient's specific needs. And that's one of the advantages that we're able to get if you're able to get the appropriate mechanical properties. I will end with this. I work with one of the most accomplished group of people that I've ever met in my life. We have an unbelievable engineering team, an unbelievable group of people that we've been able to get to from some of the best companies in the world. Craig Carlson was a VP of firmware and electrical integration at Tesla for 7 years, was VP of engineering at Intuit for 15. We were able to convince him to join, and he's been a Pied Piper from bringing great talent in the Valley to us. Joe, who is a CEO who was supposed to be giving this talk, who also had an injury or got sick last minute, so I came and gave this presentation not really knowing what his slides were looking like, but it ended up being hopefully not too bad. I would have definitely done the order differently. Joe and I, you'll recognize the same last name. He's my father. He and I started that company in 2012 in our garage. I was finishing up an e-commerce company at the time, and we were able to get some great funding from great investors and move out here and do something special. Again, as I said before, we've got 135 people on our team today, including Alex, who will help kind of walk through some of the things from a cultural standpoint, which is, again, as we're talking about differently. Can you use that? I don't know if that's turned off.
Hello?
Oh, there you go.
Thanks, Bill. So when I joined about 8 months ago, and I was about to accept my offer, I asked my friends for advice, should I accept this offer or not? And they said, well, this sounds like a hardware company, and you're a software engineer. Why would you go that route for your career? You should join a software company. There's so many in the Silicon Valley. But I joined despite that, and honestly, the best part about working at Carbon is the fact that I can interact with so many different people, materials engineers, hardware engineers, and as a startup, you can interact with the finance department, HR, sales, customer service, and that's the best part of my job. So I'm a software quality assurance engineer, and you might think, oh, all day I just push buttons on the user interface, but there's more than that. There's, of course, the part where the customer has to actually print and upload their part and see it and make sure it all looks good. But behind the printer, there's actually a lot of software that's going on. Part of it is making sure that, oh, when the light is shining, you want to shine it for the right amount of time, and that depends on the cross-section of the part, the geometries, how the part's going to turn out, the different kinds of resins. There's also a lot that goes into part accuracy, where something that might shrink because of the heat in the resins, you can account for in software. It's not something you have to solve for in hardware. And of course, there's a bunch of the release and everything I drive, and code stability. And a lot of the different cross-sections that we work with, this all contributes to our culture. And compiled a slide with a bunch of pictures that I've taken over the past 8 months. Being able to work with so many different people brings a lot of diverse views, and the creativity is just enormous. You can see the materials team here. They dressed up as Mario as part of our Halloween celebration. We also have a bunch of dogs in our office. It's an open office, and just spawn a lot of creativity, and it's very open and accountability. In the bottom right picture, you can see that the dog and the software engineer have a cone on their head because dog just got surgery, but in software we have, if you break the build, you have to wear a cone or have it on your desk. So she also broke the build that day.
There's nothing like public shame.
Yes. And we are lucky to be in a great city. I commute from San Jose every day, which isn't the easiest commute, especially on the rainy days, but I look forward to being here every day. My favorite part of the day is going out for lunch. We're walkable distance from Redwood City, and there's so many great restaurants. I found a new bubble tea place, and it helps that there's the only Dairy Queen, I think, in the Bay Area is also in Redwood City, so my ice cream intake has quadrupled pretty much since I've joined. I also took this picture outside our company of the sunset. It was really good that day. And of course, having working at a 3D printing company, it's really cool because you can print whatever you want. So those are some of the hedgehogs that I printed by mixing some colors together. So just wanted to thank the community letting us be here. We've really had a good time. And thank you for the words. And
one more statement. We are actually in the middle of moving too, but unlike the companies that left, we're actually staying in Redwood City. So we'll be going to a new facility that we're pretty excited about opening. Hopefully within the next 6 months. We need it. But yeah, I appreciate everyone hosting us today and giving us this honor. Thank you.